All right, we're now going to talk about equating coefficients. So if two polynomials are equal, then their corresponding x to the power of n coefficients must be equal for all n. Okay, so what does this mean? Well, let's answer this question for us, and you'll see what it means to equate coefficients. It says the polynomial this can be written in the form this, where b, c, and r are real numbers. Find the values of b, c, and r. Okay, so what are we told here? Well, we're told that this is equal to this, right? Because this can just be written in a different form. So let's begin by writing that out. We know that x cubed plus 3x squared plus 2x plus 1 is equal to x minus 2, x squared plus bx plus c plus r. The next thing that we can do here is we can try to get them so they look the same. Well, how is this different to this? Well, as you can see, it's been factorized. I've got these brackets here. So if I want this to be in the same form as this, all I have to do is expand this out. And that's what we're going to do now. We're going to expand this out. We're going to expand it out. So let's go. It's going to be equal to, so x, I'll rewrite this left-hand side first. So we've got this, that stays the same. And then over here, we're going to get x cubed plus bx squared. X times c is plus xc. Then I'm going to get negative 2x squared, negative 2bx, and then I'm going to get negative 2c plus r. Okay, then the next thing that we're going to do here is, I'm leaving my left-hand side the same. Perfect. But now, can I gather anything up? Well, I've only got one x cubed term, so that stays where it is. But now, let's have a look. Do I have another x squared term? I do. I have negative 2x squared. So let's just write them next to each other. Let's write plus bx squared minus 2x squared. Do I have any other like terms? So let's have a look. Let me grab another color here. I have xc and negative 2bx. So as you can see, these both have x's in them. So let me write them next to each other. So I have plus, and I'm going to write this as cx, and then this is negative 2bx. And then the last thing I have is negative 2c plus r. And would you agree that that's kind of like a constant because it doesn't have any x's with them? So I've got negative 2c plus r. So hopefully you can see what I've done here. I've simply gathered together things with the same as you can see here, x to the power of n. So here I've got my x squared. How do you pluralize that? I can't talk. Then I have my x's, and then I have things with no x's at all, which is there. Okay. Next, let's rewrite it again. X cubed plus 3x squared plus 2x plus 1 is equal to x cubed. What I can do with this is I can take out the common factor of x squared here, which means I'm going to end up with b minus 2x squared. Do you see how that works? Because now if I was to expand this out, I would end up with that. So I've just taken out that common factor of x squared. And I can do the same here. I can take out that common factor of x, and what I'm going to be left with is plus c minus 2b, then an x out here. And then I've got negative 2c plus r. Okay, now this is the important part now. What I can now do is the following. I can say, well, do you see how whatever the coefficient of my x cubed term is, has to be equal to what it is over here. I'm equating the coefficients. Now, in this case, would you agree that the coefficient of the x cubed is 1 here, and the coefficient of the x cubed here is also 1? So, that's nice and easy. But let's now go to the next one here. So if I come over here, would you agree that here is 3x squared, and over here is b minus 2x squared? Well, what that means is that this 3 has to be equal to this b minus 2 because they're both in front of the x squared. So this 3 has to be equal to this because they're both in front of the x squared. What we're doing is equating the coefficients. Hopefully that makes sense of what I'm doing there. So I'm going to write it down. I'm equating the coefficients of x squared. So that means I'm saying 3 is equal to b minus 2. That means 1 is equal to b. Oh, sorry, not 1, 5. 5 is equal to b, because you're going to plus 2 to both sides. And then we continue. Let me grab another color. Here, 2 is in front of my x. Here, c minus 2b is in front of my x. That must mean that these two things are equal. So I'm going to, again, equating coefficients of x. And that's going to be 2 is equal to c minus 2b. And now we know what b is, don't we? We know that b is 5. So this is going to be 2, 5, which means 2 is equal to c minus 10, which means 12 is equal to c. So you can hopefully see what's happening. We are slowly getting all our answers. And then the last thing we have to do is we have to say, all right, here is my constant, and here's my constant. So now I'm going to equate those. So I'm going to come here. And the last thing I'm going to do now is equate the constants. Equate constants. Okay, so that is 1 is equal to negative 2c plus r. I know that c is 12, so I'm going to put 12 there, plus r. This is going to be 1 is equal to negative 24 plus r. 25 is equal to r. So let's now grab the correct color. And there we go. Oh, that's not what the color I wanted. Try again. We've done it. All right, let's pause for a moment and reflect on what we've done here. We were told at the very beginning that we had two polynomials just written in different forms. One was expanded, one was factorized. So what we did is we expanded the factorized version. We gathered the like terms. We then made it so that we had coefficients of the x cubed, the x squared, the x, and then we had the constant by itself. We then could equate the coefficients of each of the corresponding ones. Following this, if two polynomials are equal, then the corresponding x to the power of n coefficients must be equal for all of n. And that's what we did. We just equated all of the relevant coefficients and we solved. Hopefully that made sense, and hopefully you enjoyed this video.